today we're going to be working on solving inequalities, okay? And you've probably done this before in the past, however, you probably haven't necessarily seen an answer written in this form, okay? So this is an answer to an inequality problem, and this is actually what's referred to as set builder notation. Okay, so what I'd like you to do is write this down in your journal, and we're going to break it down into two parts. Okay, we're going to break it down into this part. I'll color it in blue, and we'll color this part right here in red. Now you've probably seen these brackets, like this bracket here and this bracket here. It lets you know that you're building a set. Okay. However, right here, I would like you guys to write in words the set of all x values such that. So this right here is going to be basically, just in words, the set of all x values such that, that's kind of that line right there, that x is greater than 9. So if you wrote a whole sentence, you would just say the set of all x values such that x is greater than 9. So you have two parts to that set builder notation. That's something you have to get used to writing when you're going to be working through these inequalities. Next thing we're going to look at is, well, how would we graph this? So when I'm looking at your graph, what I want you to do is whatever number you're graphing, right here in the middle, I'll put the number 9. You don't have to write a whole bunch of numbers on the number line. I just want to know that you know that 10 is on the right side, 8 is on the left side. So you can make your graph in your journal. And I want to see that all numbers, all right, so right here I'm going to put the domain for our graph is going to be all real numbers. So it includes all those irrational numbers and rational numbers. So domain is all real numbers. We got to figure out how do we graph. X is greater than 9. All right, so Cody, you said we're going to make a circle right here that's not filled in. Kind of like basically right here. That means it does not include 9. Does not include the number 9. So if it's open, it doesn't include it. Okay? Anybody ever remember that game, that annoying kid that played in your elementary school, not touching you? They get really, really close to you, but they don't. Oh, it's so annoying. All right. Well, if it's open, all right, it doesn't include the number. What would we do if we wanted to include the number? We actually do what? We fill it in. So if you don't do this on your paper, all right, don't fill it in. I'm not being sarcastic. I'm actually don't fill it in on your paper. Because if I filled it in, that would mean that there was an equal to sign underneath it. Okay? But we don't have an equal to sign underneath that greater than symbol, so we're not going to fill it in. But we are going to shade somewhere. So where are we going to shade? Where x is what? Greater than 9. So that'd be everywhere to the right of the number. So what I want to make sure, whenever you guys have an answer on your paper, make sure I can clearly see which direction it's going. So if it's less than, make sure you shade to the left. If it's right, greater than, make sure you're going to the right. Okay? It's kind of interesting. One student's like, well, how do you remember? Like, well, you see how that arrow's pointing? It kind of lets you know which direction that you need to go. If and only if your variable's on the left-hand side. That won't work if your variable's not over. Okay? So that's basically the two things I want. I want something written in set builder notation, and then I want a graph. That's what I'm looking for on all of these. So we're going to do a difficult one together. Okay? So you guys have number 10 written down already, so we're going to do that one together. What I would like you to do is I would like you to write in sentences, step by step, how we solve the problem. Okay? So step number 1. What's the very first thing that we're going to do throughout this whole inequality? So step 1, we're going to distribute. So I'm going to highlight this positive 5 right here. And I'm going to highlight this negative. But I don't want you to just think of it as a negative. Actually, think of it as a negative 1 that's sitting right there on the outside of that parentheses. So I want you to distribute the 5 to the x and to the negative 8. I want you to distribute the negative 1 to the x and the negative 1 to the 5. So step 1, in blue I'm going to write distribute. Okay? The 5, distribute the 5. And I'm going to say the negative 1. Even though you can't see it, think of it as a negative 1 that's out there. Okay? When we do that, I'm just going to bring the 1 down. We now have 5 times x. Then we have 5 times negative 8. What's that going to be? Negative 40. Good. So we have 5x minus 40 is less than or equal to 2. What's a negative 1 times an x? Negative x. And what's negative 1 times a 5? Negative 5. Good. So we've just accomplished that very first step. I'm just going to make sure we're aware that we have an inequality sign right here. So the first step is done. Step 2. What I would like you to do is I would like you to combine like terms on the left side of the inequality and the right side of the inequality. Combine like terms on both sides. When I say both sides, I'm referring to combine like terms on both sides of the inequality. I'm going to highlight our like terms in red. I've got a 1, and I've got a negative 40 here. Those are like terms. I've got a 2 and a negative 5 right there. All right? All right, so we're going to combine the 1 and the negative 40. And JC, what do we get when you do that? Negative 39 is correct. But negative 39, I'm just going to put plus 5x is less than or equal to, all right? Then, Madeline, what are you going to get here? 2 minus 5. Negative 3 is correct, but minus 3 minus x. So what we did here is we combined the like terms. 1 minus 40, negative 39. 2 minus 5, negative 3. And we're done on that. Now we have to make a decision. We can either move all the constants to one side or all the variables to the other side. So, what I'd like to do is I would like to isolate all the variables. Isolate the variables to the left-hand side. To the left of the inequality. Now, there's a reason why I'm going to the left and not the right. Over here, notice, we have what? Positive 5x's right here. All right? So, if I have positive 5x's already over there, what could I do to get rid of this negative x on both sides of the inequality? What are we going to do? We're going to what? We're going to add an x to both sides. So right here, add an x to both sides. Scroll back over. So what we're going to do is we're going to add an x to both sides. So watch how I do this in green. We're going to add an x here, and we're going to add an x there. All right. All right. Now when we combine all the like terms right here, we're just bringing down the negative 39. 5 x's and 1 more x gets us to what? 6 x's. All right. Garrett, we're not talking about your date. We're talking about variables right now. Just kidding. We're going to bring down a negative 3. Now this one, what happens to these? These just, they zero out. So now, do we have all the x's on one side? Now we need to get all the what? All the constants on the other side. So here's step number 4. All right? So right here, put isolate all the constants to which side? To the right. So put isolate all the constants to the right side of the inequality. So I'm going to put in parentheses. What are the instructions to moving all the constants, and those kind of to the right side? What are we going to do? Add 39 to both sides. Good. So we're going to say add 39 to both sides. 39 to both sides. So I'm going to add a 39 to this side. I'm going to add 39 to this side. Looks like we're running out of room. So this zeroes out. We're going to come down here. We're going to have, it looks like 6x. I'm going to bring this down. Less than or equal to. Now when we combine these right here, what do we get? 36. Very good. And finally, we're down to the final step. What is going to be the very, very, very final step? Divide. Divide both sides by the number in front of the variable, which is 6. We're going to divide both sides by 6, and x is less than or equal to 6. Now this seems pretty easy if you do things step by step, but if you do something out of the order of operation, you would not get to that answer. If you messed up on one of the order of operations, you would not get to that. Now this is what you're used to. What we want to do now is we want to take this answer and we want to put it in set builder notation. So we got to get you guys used to writing in set builder notation. So in your journal, this is what you're going to write, and you're going to transfer it to your paper. You're going to write the set symbol. You're beginning a set of all x values such that x is less than or equal to 6. This is your answer in set builder notation. So write that down in your journal and then transfer it over to your paper. So here's our answer in set builder notation. Now we're going to graph it. So remember what I told you. How do I want the graph? Just put the number 6, all right, somewhere on your paper. Put the number 6 to the right. Make sure you put a 7 to the left. Make sure you put a 5. Now, this one's going to be a little bit different because now you're actually including the 6. It says equal. It says less than or equal to. So you have to fill it in. All right? So you have to fill it in. And which direction are we going to shade everything?
To the right.
I don't know. I'll give you it. It's either to the left or to the right. All right, now look, remember what I said. If you solve it and you have the variable on the left-hand side, the arrow says, no, it says x is less than or equal to 6. So it means we're going this direction. Now do you kind of see, if you solve it correctly and you have the variable on the left-hand side, look at which direction that little tiny arrow is pointing. So that gives you a hint of where you're going to shade. Okay? This is, remember, it says x is less than or equal to 6. So you're going to have this on your paper, and you're going to have your answer in what? Set builder notation. What I would like you guys to do right now is I'd like you to start solving the ones that you think you can do that are easy. We're going to start with number 1. Just start with number 1 and start solving that one all by yourself. All right, so look at number 1. That's number 2. Number 1, nice and easy. I want you to graph it. I want you to write your answer in set builder notation and see what you get. All right, Aspen has volunteered to solve this one. She has 1.5 minutes to solve it. Looks like she's adding 6 to both sides. Do you guys agree with that? I agree with it. Good job. Keep going. So now she has 8x is greater than or equal to 16. What's she going to do next? Divide. Good. She's dividing by an 8. She's dividing by an 8. And she gets x equals, not equals.
How many?
Go ahead, you can change it. You're like, how do you change it? You can. There you go. That's better. Now, can you write that in set builder notation? There you go. That's a beautiful bracket right there. X such that x is greater than, equal to 2. Oh, that's a great closed bracket. Now, you see this double arrow right here? This double arrow? Hit that double arrow right there. Good. Now you have room. Now, I want you to graph that. Graph it. She's got 30 seconds to graph. She's doing good. She's closing the dot. And she's shading everything where? To the right. If you put that on your paper, I would accept that as one whole point of being on the right. Very good. Go down here where it says pause.